This video is a run-through of how I built the event processing demo to summarize weather data using watsonx. If you just want to see the flow in action, I've got a much shorter 1-minute video that does that. This video is about going step by step, a walkthrough of how I built the flow in case you want to use it to build something similar yourself. So the starting point is bringing in that source of weather events. So for that, I went to Event Endpoint Management because I had a topic in the catalog with readings from a weather station. This topic gets an event every 2 minutes with a whole load of sensor readings from the sensors in this weather station, things like temperature and humidity and so on. So I give this a name, including that detail that it's every 2 minutes, which is useful when you're building your flow. I use the event gateway address to connect to. And then I just need a username and password credentials to access this topic. And I can create that from the EAM catalog. So this username and password is just able to access this topic, which is what I need for this project. This then fetches the most recent message from the topic, so it's recognized that there are JSON messages, and this most recent message is enough for it to recognize the shape of messages on this topic. And that's what I can see here. I don't need to make any changes to this, but I can see the different kinds of fields that I'm going to be able to get from these events. The only thing I need to change is I don't want lateness and I don't want to save this. I'm just going to use it for this one project. It's useful to check messages. Every time you make a change to your flow, you should run it again and check that it's what you expect. So what I can see here is that historical data on the topic, that history of previous weather readings. So this is what I'm going to use for this project. The idea for this flow is that instead of looking at any one weather reading in isolation, it's more useful, it's easier to understand if you look at it in aggregate, if you look at what happens over longer periods of time. So the next step, I added this aggregate node, and I'm going to use this to create hourly aggregates of the weather readings. So I create a 1-hour window, and then I need to specify which values I'm interested in. Now this took a little while, so I'm going to speed through it in the video. It's not as complicated as it looks. All I'm doing is, for each type of sensor that I'm interested in, like temperature, I want to know what was the highest value that was recorded during the hour, so I used max. What was the lowest value that was recorded during the hour, so I used min. What was the average reading seen across all of the measurements over the hour, and with average. And finally, what was the amount of variation in reading seen over the hour, so I'm using standard deviation. So all I did was repeat these 4 aggregates, max, min, average, and standard deviation, for all of the different types of sensor that there were. So I started with temperature, moved to pressure, and so on. So there are a lot of values, and this did take a few minutes to go through all of this, but it's pretty straightforward if you know what you're after. The next step was to give all of these values more friendly, more human readable names. Now you don't have to do this, but I find it easier to refer to these variables later on in the flow if I've given them names that are a bit simpler to refer to. Again, this did take a little while, so I'm speeding through it in the video. But all I'm doing here is going through each of the values in turn, the max, min, average, and standard deviation, and giving that a name that I find a bit easier to follow. You can obviously call these values whatever you want, as long as you remember what you've called them when you refer to them later on in your flow. As before, the next thing to do is to try this out. So again, I'm running it with those historical weather events. And this time what I'm getting out are the hourly aggregates. For each of those types of sensor that I'm getting from that raw stream of events, I'm getting the max, the min, the average, and the standard deviation. Notice that I'm not using all of the data from the original events. For example, there's weather direction in the raw events as well. But as you saw, it did take quite a while with the values that I am using, so I thought this was enough to do a decent demo. The next step is to turn this into a prompt for a large language model. So I'm using a transform node for this. The idea of this is to generate the prompt that I'm going to send to watsonx with a request to summarize the data. The function I'm going to use here is concat. Concat can join strings together. So this is an easy way for me to combine all of that data from the aggregate node into a single string. So you see here, first and second, this would produce a single string with that combined first second. In the interest of time, I've prepared my prompt ahead of time. So this is a concat expression, SQL expression. I'm also using some rounds, so that particularly with those averages, so I don't get too many decimal points. But otherwise, all I'm doing is combining that together and then ending this list of data with a request to summarize it in simple language. Then I get rid of all the raw numerical data because I don't need it anymore. The only thing I need going forward is that prompt, and I keep the timestamps on there just so that I can keep track of what each event is for. As before, I test it out again. So this gets me the prompt that is generated for each hourly window. If you want to see the contents of this, you can hover over it, or you might find it easier if you pause the flow, you can export the data to a CSV file, and then you can review it in the CSV file and check that you've got the prompt the way you want it. The next step, now that I've got the prompt ready, is to submit it to the watsonx API. You just need an open API document that describes the API you want to use. So I upload that here. Choose which of the APIs described in that document, which of the operations in the document you want to use. I do need credentials for this API. So once I've picked the server, I just need to pick the auth mechanism of basic and plug in my username and password. Now there's two input parameters I need here. One of them is which model I want to use because there's a few to choose from. So this is a constant. I'm not getting this data from the individual events. I'm just plugging that in as a hard-coded value. And the other thing is the prompt itself, the message I want to give to the large language model to generate the text. As before, I can rename the responses I get. So I'm just going to get rid of some of the values that I get back in the API because all I want is the text that was generated by the model. And I'm calling that summary. So that is pretty much everything. The only thing left to do is to add in an event destination, a sync topic, so that every hour the summary generated by watsonx can be sent to a Kafka topic. So then I can use it to maybe do some sort of notifications, or if I use some change data capture, some sync connector, I can sync it to a database and use that to drive some web app or some mobile app or something like that. So the end of this flow is just putting in the credentials, choosing the topic where I want to send these summaries to, and then I can start it running. You can see the summaries displayed in the event processing UI. As before, it might be easier to read if you pause the flow and export it to a CSV file, or if you just go and look at the messages directly on the destination Kafka topic. It's much easier to read there. So to sum up, this is a stream of weather sensor events that have been aggregated by Flink in a flow created in event processing. Those aggregates have been submitted to the watsonx API with a prompt to summarize the data in plain language. The output from all of this has gone to a new Kafka topic. So what I've got here is a topic that every hour gets a plain English description, a summary of the weather events that have been recorded over that last hour.